All right, today we are going to jump into lesson 1.2, which has to deal with powers and exponents. All right, so we should have already filled out our name, period, and date, just like we always do as soon as we get our paper. And the next order of business is to fill in that learning target for today, which is I can find values of powers. And no, we're not talking about magical powers. All right, we're talking about mathematical powers. So first let's start off with some vocab. So what is a power? Okay, a power is a product. Remember, product means multiplication. So we're going to do some multiplying. It's a product of repeated factors. So what that means is the same number being multiplied by itself over and over again. So 5 times 5 times 5. Okay, or 3 times 3 times 3 times 3 times 3. It's a product of repeated factors. The base is going to be that repeated factor. Okay, so that is the 3 that's being multiplied that however many times. So we can, in parentheses, put the number being multiplied. That's what we call our base. Okay, an exponent tells us the number of times the base is multiplied. Okay, so let's put that into a visual. So right here, this 3 to the 4th is a power. Okay, 3 to the 4th is a power. That little red 4, that small 4, we call an exponent. Okay, the 3, the big number 3, is the base. Okay, and this right here is showing us that 3 is being multiplied 1, 2, 3, 4 times. So 3 is being multiplied by itself 4 times. Okay, so 3 is being multiplied I write big, sorry, 4 times. Okay, a perfect square. So a perfect square is the answer to when a whole number whole numbers are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, whole numbers are not decimals, they are not fractions, they're just whole numbers. So it's when a whole number is multiplied by itself. Okay, so for example, 5 times 5 is 25. So since 25 is the answer to a whole number being multiplied by itself, 25 is considered a perfect square. Okay, and we'll talk about how we can determine if a number is a perfect square once we get to those examples. All right, so let's put all this vocabulary to use and do some examples. Now there's different kind of problems that we're going to be asked to do. Okay, writing expressions as powers. So this is what we call an expression. It's not an equation because it does not have an equal sign to a number. Okay, it's an expression. So we are going to write this expression in this format. Okay, so we have our base, which is the number that's being multiplied, which in this case is 4. So 4 is our base. It's going to be our big number, just like that 3 was. And 4 is being multiplied by itself 1, 2, 3, 4, 5 times. So our exponent, our little number, is 5. Okay. and that's a power. So it's 4 to the 5th power. 4 being multiplied by itself 5 times. All right. Here we have 12 that's being multiplied. So 12 is our base, our big number, and it's being multiplied by itself 1, 2, 3 times. So this is written as 12 to the 3rd power. All right. I would like you to pause the video and try these next 2 examples on your own, and then resume the video to check your work. All right. So here we have a base. So if you're watching this, you should have already done this. You're just checking your work. We have a base of 6. 1, 2, 3, 4, 5, 6. And we are multiplying it by itself 6 times. So we have 6 to the 6th power. Here we have 15 being multiplied. So that is our base. Our big number, our base. Both start with a B. And then it is being multiplied 1, 2, 3, 4 times. So our exponent is 4. 15 to the 4th power. All right, now we're going to learn how to find values of powers. And even if you know how to do this already, I want you to watch this because I'm going to show you how you need to show your work. Okay, this is how you're going to have to show your work on a quiz or a test. So please pay attention. And there is no shortcuts. You have to do this. All right, so 7 is our base. 7 is our number that's being multiplied. And our exponent tells us how many times it's multiplied. So in this case, 7 is being multiplied 2 times. So we have 7 times 7. You have to show this step for your work. All right, and then underneath that you can write the answer to 7 times 7, which is 49. And we should circle our answer since we're showing some work here. So for letter B, 5 is our base, so 5 is being multiplied. And our exponent tells us how many times it's being multiplied. So 5 to the 3rd is 5 being multiplied 3 times. Now remember when I said we cannot multiply 3 numbers all together at once. So we have to group 2 together. So 5 times 5, we're going to group together to be 25. And then we're going to bring down that last times 5. And we're going to do 25 times 5. Now, if that's not mental math for us, that's okay. Pull it to the side. Take 25 times 5. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. So we get a final answer of 125. Circle that answer. All right, I would like you to pause this video and try the next 2 on your own. Make sure you are showing all of your work. All right, so if you are watching now, you should have already paused the video and have these 2 answers already completed. And you are just watching this to check. So 6 is our base. 6 is being multiplied 3 times. So we have 6 times 6 times 6. We have to group 2 of those together at a time. So 6 times 6 is 36 times that last 6. I'm going to pull it over to the side so I can show my work. 6 times 6 is 36. Write our 6, carry our 3. 6 times 3 is 18, 19, 20, 21. We get a final answer of 216. Wait, hold on. Yeah, wait, that's correct. Okay. Sorry, I just caught a mistake on my answer key. I said that 6 times 3 was 24 when it's not, it is 18. So the answer is 216. Sorry about that. Number 4, we have 9 as our base. 2 is our exponent, so 9 is being multiplied twice. 9 times 9, easy peasy. 81. All right, so that is writing expressions as powers. You'll have to do that on a quiz and test. And finding the value of powers, you'll also have to do that on a test. Perfect squares. So we talked about these before. So let's review. A perfect square is an answer to when a whole number is multiplied by itself. For example, 5 times 5 is 25, so 25 is considered a perfect square. So now we're going to be given numbers and they want us to know, to find out, okay, if they are perfect squares. So we want to start with a whole number. So I'm going to start in this case with like an 8, okay, because I know 8 times something gives me close to 64. And I have to multiply it by itself. So 8 times 8 is 64. Since 8 times itself, a whole number times itself, is 64, yes, this is a perfect square. So these are kind of like yes or no questions. Okay, and to show our work, we would just show that it's a whole number times itself. Okay, so we would just show 8 times 8 is 64. 20. Okay, well I know like 5 times 5 is a whole number times itself is 25, which gets me close. Okay, but 25 is a little too big, so I have to go down to the next whole number. The next whole number is 4, because remember, you cannot have fractions or decimals. Next whole number is 4. 4 times itself is 16. Since there is no whole number in between 5 and 4, and 20 is somewhere in between 25 and 16, it is not possible for 20 to be a perfect square. So our answer here would be no. Okay, and this is how we would show our work. We'd show our work of the perfect square above 20, 5 times 5, and the perfect square below 20, 4 times 4. Okay. Try the next two on your own, so pause the video, try these on our own, and then resume the video to check your work. So if you're watching now, you should already have these two answers written down, and you are just checking your answers. 9 times 9 gets me somewhere close to 99, so that gets me to 81. That's a little too low. All right, 99 is bigger, so I do need to know if 10 times 10 is going to be 99. But 10 times 10 is 100. Since there is not a whole number that is in between 9 and 10, and 99 is in between 81 and 100, 99 is not a perfect square. Number 6, 25. We've used this number many times today. 5 times 5 is 25. Since it's a whole number times itself, 5 times 5, yes, this is a perfect square. Okay. Just one last word problem, and then we are going to get moving on to practicing. A Monopoly game board is a square. So it's a square, meaning that all the side lengths are the same. And the side length is 20 inches. We want to know what is the area. Remember, area of a game board is what's inside. Okay, the space inside. What is the area of the game board? Remember, to find the area of a square, it's a side length times a side length, or the side length squared, because it's a side length times itself 2 times. So our side length in this situation is 20. So in order to find it, we do 20 squared, or 20 times 20. We'd have 2 20s, 20 times 20, which we can pull to the side and do our multiplication. And I get an answer of 400. I need a label, inches. And when we're doing area, since it's 20 inches times 20 inches, it's inches squared, because it's inches times inches is inches squared. So if you never knew, that's why we label area squared. That is why, because it's 20 inches times 20 inches, and inches times inches is inches squared. Learn something new every day. All right. So I would like you to take a couple minutes, fill out your summary. Again, aim for 3 sentences. Sentence starters could be, today I learned what a base was. I learned how to find the value of a power. The base tells me what number is being multiplied. The exponent tells me how many times it's being multiplied. Any of those pieces of information would be good to include.